Okay, we're going to start again at problem number 3. A wooden rod 60 inches long is sawed into two pieces. One piece is 6 inches longer than the other. How long is each piece? So the first thing you want to do is set up your two pieces. It doesn't matter what you call them. Piece A, piece B, piece 1, piece 2. It doesn't matter. And as we read through this first sentence, all this is going to give us from the beginning is that we have two pieces. We need to move on to the second sentence where it says one piece is 6 inches longer than the other. So just call one of the pieces X. And then we know the other one is 6 inches longer than the original, or the other piece. So you could write X plus 6, or you could write 6 plus X. It doesn't matter. Longer than, you can put the 6 on either end there. Now, here you have to go back to how long the wooden rod is in the beginning. It's originally 60 inches long. That means these two pieces, when you add them together, should equal 60 inches. So when we add these two pieces together, we get 2x plus 6 equals 60. We're going to subtract the 6 from both sides, and we get 2x equals 54. Divide by 2, and we get x equals 27. Now don't write your sentence yet. Let's go back up and plug these in. Piece 1 then would be x, 27. Piece 2 would be 27 plus 6, which would be 33. So 27 plus 33, does that equal 60? Yes. And then and only then do you write your sentence. You can say the two pieces are, because it doesn't matter which one's which. The two pieces are 27 and 33 inches long. Okay. Now, we have a different kind of problem. I call them the also problems that aren't quite as easy as those. They have a nice little twist in there and require that we talk about them separately. So in an also problem, you see that word also means we have to do something else. So keep an eye out for that word also. It tells you should treat it like these two problems here. Brenda drove 3 times as far as John. Now I'm going to stop right there. We know we're talking about Brenda and John. So Brenda drove 3 times as far as John. Now you're going to ask yourself the same question. Which one do we know nothing about? Is it Brenda or John? Now we know Brenda drove 3 times as far as John. So it's John that we know nothing about. So we're going to call John J. And we read it again. Brenda drove 3 times as far. So if John drove J miles, then Brenda drove 3 times as far, 3J. So far it's been normal. Now here's where it's different. Brenda also drove 24 miles more than John. So as soon as you see that word also, you realize that they've given us one statement for Brenda, and they're also going to give us a second statement for Brenda. These are two separate statements. The first one's based on this first sentence here. The second statement is based on this sentence. Brenda also drove 24 miles more than John. So more than means we flip it. So 24 miles more than John, J. These are two separate statements. One for the first Brenda sentence, one for the second Brenda sentence. And notice there's no total. Okay? So we're not going to add down and total these up. However, we know that Brenda drove a single distance, and these are two expressions that represent the single distance that she went. So if these two represent the same mileage, then they should be equal to each other. So in an also problem, once you set up your two statements, then you set them equal to each other. So here's our equation. 3j equals j plus 24. We have variables on both sides, so we move that j over by subtracting j. We get 2j equals 24. If we divide both sides by 2, we get j equals 12. Now what do we do here? How do we check this? We know John is j, so John would be 12. Brenda is 3 times j, so 3 times 12 would be 36. Let's check this one. John is still 12. 12 plus 24 is also equal to 36. So in an also problem, when you're trying to check your answer. When you plug it back in, these two should come out to be the exact same mileage or the exact same value, in this case mileage. So in this case they did come out to be the same, so we can write our sentence. Brenda drove 36 miles and John drove 24 miles. So why don't you give number 5 a try all by yourself without any help? Go ahead and push pause, give that one a try, and then come back and check it. Okay, let's see how you did. An oil painting is 16 years older than a watercolor by the same artist. So right away you should write oil, watercolor. Then read it again. An oil painting is 16 years older than a watercolor. Which one do we know nothing about? The oil painting is 16 years older than the watercolor. The watercolor is the one we know nothing about, so we call it W. Now, if the oil painting is 16 years older, then you take the watercolor's age and add 16 to it. No problem. Now, the oil painting is also. So for the oil painting, we're going to have two statements. The first sentence and the second sentence. 3 times older than the watercolor. So if the watercolor is W and it's 3 times older, you do 3 times W. Once you have your two statements set up, then in an also problem, remember, you set these two statements equal to each other. W plus 16 equals 3W, and you solve. Variables on both sides, so we take this W, move it over by subtracting W, and we get 16 equals 2W, divide by 2, and we get 8 equals W. You're not done yet. Let's check these. That means the watercolor is 8 years old. 8 plus 16 is 24 years old, and 3 times 8 is also 24 years old. So these come out to be the same, so we know we did this right. How old is each? The oil painting is 24 years old, and the watercolor is 8 years old. Remember, you can always go back and rewind. Oops, we ran out of page there. There we go. There's the rest of the work. You can always go back and rewind if you have any questions about any of these or are confused or you just need to watch it again.